So yeah, my name is Nick, founder of Clockwork, and we're going to talk a little bit today about automation and how to automate on-chain programs, particularly on Solana, but soon in the multi-chain world. So a little bit of background about myself. I've been building apps for a little over 11 years. I started in iPhone game and app development, where I had some moderate success early on in high school or so. When a productivity app I launched did 100,000 downloads, and then I was making $100 a month, and that was what really got me hooked on startups and building software for people. So I ended up going to the University of Illinois to study computer science, and after that moved out to San Francisco and joined the payments team at Uber, where I worked there for about 4 years. And there I helped the team basically build out the payroll system that pays income to all the drivers around the world. And this involved a lot of international banking integrations with Citibank, Wells Fargo, Deutsche Bank, et cetera. And it was while working on that I came to realize just how arcane, kind of broken, and frankly insecure the legacy payments infrastructure is that the whole world depends on. And it was a little frightening. I have to tell you, I can't even describe the number of times I got woken up at the middle of the night at 4 a.m. because some system broke somewhere, and we had to email a CSV file to a banker on the other side of the world to make sure that drivers would get paid and have enough money to put gas in their cars and food on the table. And this came to set up why I eventually went into crypto, eventually. Yeah, I left Uber in the very end of 2019 and basically dove back into the startup world. And in early 2021, I heard about this thing called Solana. And it's a little bit embarrassing to admit to this crowd, but I was a crypto skeptic for a really long time, up until very, very recently. And I'd heard about crypto, obviously. I'd heard about Bitcoin in college and Ethereum a few years after that, but it just never made any sense to me. It didn't make any sense why someone would want to pay $20 in fees to send $5 to a friend. And and even worse, it might take 20, 30, 60 minutes for that transaction to settle. And so I just didn't understand why people were using these systems or what they were using them for. And then Solana was kind of the first network or solution I had ever seen that basically was cheaper, faster, and easier to use than any existing payment rails that currently exist. And that was really what kind of caught my attention and pulled me into the field. And I mean, best of all, Solana was open source and it ran on decentralized infrastructure. So anyone could come and spin up a node and suddenly become a network participant and power this thing. It didn't run out of some PayPal or Braintree. And so when I initially kind of saw Solana, I saw it from that payments perspective, and gears were turning in my head, and I was just well, we should build a payroll system on Solana. It seems like a very natural, just kind of companies like Uber spend literally tens of millions of dollars a year on fees to companies like Visa and MasterCard and banks around the world to process their payments. And if they would save so much money, frankly, by pushing the riders and drivers to download wallets and just settling on Solana. That's not going to happen for some time because of organizational inertia, but it makes sense that these financial systems will move to a system like Solana. But it's particularly while working on that payroll system that we kind of began, the team and I that I was working with, we began to run into this problem, which was basically how do we schedule a transaction to happen? How do we schedule a token transfer to someone's account to happen every day, or every week, or every month? And the longer we looked into this, we became more and more unhappy with the solutions that were available. Because what we wanted was for some just like native API on the blockchain for us to say like, hey, we have a transaction, can you run this next Monday? Or like, can you run this every Monday? And that's just like not how the blockchains really work. It's not how they're designed. Really what needs to happen is someone needs to build a transaction, sign it, and submit it to the blockchain in order for the network to process it and for that to get added to the ledger. The nodes themselves can't just like add entries to the ledger willy-nilly. Like some user has to sign those transactions with a wallet and actually submit them. And so what we ended up doing, and is basically what we just saw everyone else in the space doing, because it's the only thing that really made sense, was we ended up spinning up a server in AWS or Google Cloud and coding that thing to submit transactions on an automated basis. And this works. Like we did it. It got the job done and solved our problem, but it kind of like introduced this new problem. And that problem is basically just that like I was an idealist and this wasn't the decentralized solution. In short, like we had to fall back on a centralized solution in order to automate these on-chain applications. And that was kind of like unsatisfactory to us, and where we really began to like feel that the industry or ecosystem needed an open source decentralized solution for automating transactions. Yeah. And so, let's see. So that really is what Clockwork is an automation engine for the Solana blockchain. And developers can use Clockwork to schedule transactions and to automate decentralized workflows without relying on centralized infrastructure. And so you may be wondering, like, well, so what? And like, what can we actually do with this? And already we're kind of starting to see like the power of this primitive in the way that developers are building smart contracts and writing smart contracts. Obviously, from payments, there's like payroll and subscription services that need to schedule transactions. In DeFi, you have like market settlement and liquidation engines that need to basically match orders on an automated basis. And like, right now, teams will spin up servers in AWS to do that cranking. There's reward distribution. So for a team like Helium, for example, that's like moving their token to Solana, they need to mint a new token every hour and like send it out to a miner who's powering this like decentralized radio network that they do. In gaming, there's of course like world generation and how do you do like an on-chain MPC. And then in the Oracle space, there's like ZK and VRF like proof verification. It just takes like a lot of transactions to actually get through these proofs. And right now, the teams run these bots off-chain, basically in AWS, that power those systems. And so I can almost guarantee you, like, if you're working on chain, there'll be some part of your system that you want to automate. And that's what Clockwork is here to help you do in a decentralized way. And ideally for much cheaper than you would be able to do it in AWS. So if there's really like one thing to take away from the talk, it would be this, that like this is not a SaaS. This is not run in AWS. It does not require a monthly subscription. You don't have to sign a service agreement. This is open source, permissionless software that's running entirely on the blockchain and that anyone can use. And so yeah, the important thing is that like because it's already running on the servers that like power the blockchain, if you want to use Clockwork, there's basically, you don't have to do anything. Like Clockwork is already there. You don't have to deploy a bot. You don't have to pay an AWS bill. You can simply write your smart contract with these primitives that we provide, and the blockchain nodes will automatically know how to power your program and like when to submit transactions and what exactly to automate. And it's actually quite powerful because it's running on the same physical servers that are already supporting tens of millions of transactions a day on Solana. And so that architecture ends up making Clockwork generally cheaper, more reliable, and less spammy than any sort of like SaaS-based centralized alternative. And we think it's kind of a great example of how when decentralization is like implemented correctly, it actually brings infrastructure costs down rather than making things more expensive. Like Solana is a great example of that, as well as Helium as well. So yeah, I want to like peel back the layers a little bit to like talk about how Clockwork actually works. As we mentioned, like Clockwork is an automation engine, and there's two main subsystems to that. The first is a smart contract, which is this middle box here in the diagram that we call the Clockwork program or the Clockwork smart contract. And there, users can pay Sol to create transaction queues. And I'll come back to like talk a little bit more about what transaction queues are in a moment. But the other second main subsystem is the blockchain itself and what we call the worker network, which is basically validators and RPC nodes on Solana that are running this Clockwork plugin and that know how to communicate with that Clockwork program. And so these two subsystems together, the worker network and the Clockwork smart contracts, they work together to power automations for other target programs, whatever program you're writing, basically. So yeah, those transaction queues, like what are they? How do they work? Queues are basically the primitive that like Clockwork provides to manage the state of an on-chain job or workflow. And specifically what that means is that if the queues tell the worker network which transactions to submit, and then they actually pay yields to the workers that build and submit those transactions quickly. So anyone can create a queue. Simply just go to the Clockwork program and you can ask for a queue. It's permissionless. Or you can use the Clockwork SDK to build a smart contract that itself manages an internal queue to automate that smart contract's operations. And yeah, if we peel back another layer, it's kind of like how does the queue actually manage an on-chain workflow? Like what does that really mean? And the answer is that queues break down workflows into small atomic steps that we call cranks. And a crank, put simply, is just a transaction that executes some atomic unit of work. But what makes the cranks and queues so powerful is that each crank has the responsibility of defining the inputs that go into the next crank. So this is worth like saying again, is that like each crank sets up the next crank. And so this is basically the mechanism that allows queues to respond dynamically to on-chain state changes or to take branching or even like cyclical logical paths. Basically, the queue is defining a way to manage a large complex chain of transactions. And you can write through smart contracts, if price is above X, then take branch A. If price is below X, then take branch B. And you can create real complex on-chain workflows that run automatically entirely through just smart contract scripting. And yeah, so it's worth mentioning the worker network will automatically process this queue and like keep cranking it until the queue says there's no more work to do. And that's very simple. It's just in your smart contract you can say like, hey, we're done with our job. There's nothing else to do, and the queue will stop. And you may be wondering like what actually kicks off the queues, like how do they start? And for that we have triggers. Right now Clockwork supports 3 unique different trigger types. The first is what we call the account trigger type, which basically says when the data in this particular account updates, then we want our queue to start processing. And so this can be useful for either event-driven queues, if you want some, like a queue to happen anytime some NFT is minted, Or it can even be useful for like Oracle data-driven queues, where you want a queue to process a particular price feed, for example, or data feed from switchboard. The second type is the cron type, which is kind of where the whole thing started with scheduling token transfers in like payroll systems. It's basically a cron string, a schedule that you can make either one time or recurring. And so you can tell a queue to process next Monday or every second Monday of the month. You can get like very arbitrary complex schedules out of that the second trigger type. And then the third one is simply for immediate processing. If you have a chain, a large complex chain of transactions that you want to kick off immediately, you can just create an immediate queue and it will start running. And the last thing I kind of want to touch on here is the fees. And so Clockwork charges 0.000001 sol per crank, which is a millionth of a sol, or 1,000 lamp ports, if you want to count it that way. And it's worth highlighting like just how cheap this actually is. So like the base Solana fee, every time you submit a transaction to Solana, you're paying a minimum of 5 times this amount. Like if you change that one to 5. You pay 5,000 lamp ports per signature on your transactions. And so kind of the takeaway there is that Clockwork is basically a marginal fee on top of the base fee that you're already paying. And with it, you get all this automation out of the box and decentralization. And yeah, and then it's also worth noting, like this isn't a SaaS, so it's not like this fee goes directly to us. While the core Clockwork team does like run a few workers, we don't run all of them. And so the fees get paid out to the worker network, basically, for providing these automation services. And so if anyone here actually runs Solana Validator RPC node, like we'd love to chat with you about how you can join our grant program and sign up to start like collecting these fees. And yeah, in closing, just like a few thoughts that I want to leave with, which is just, developers are building things today, and the systems that developers build today with blockchains are going to come to reshape the way that value is transacted and distributed around the world for years to come. And so we think it's incredibly important that that software that powers those markets is both open source and runs on decentralized infrastructure. And to that end, that is our goal with Clockwork, to help support teams in their missions to rewrite these games and markets in a decentralized way and make that easy to do. And so if you want to learn more, you can find our docs from our website at clockwork.xyz. Yeah, I'm available on my DMs that are open on Twitter, Time Composer, and yeah, happy to chat. Thanks for listening. What's up?
Do you have stuff that relies on like multiple of those? Like for example, like a schedule that then checks like an account, or is it like it has to be like one or the other?
No, you can totally do that. Yeah. I was trying to keep things very high level, but it just like every queue has a kickoff instruction, and that's the same. Like the kickoff instruction runs, and you can do whatever you want in that kickoff instruction, and then you just return whatever you want that next instruction to be, and then it's dynamic from there. So that next instruction could execute some transfer, look at whatever account data it wants to, and then return like whatever that next step in the workflow should be. So yeah, if you want your like base trigger to be some like run every 10 minutes, and if this account has this certain data, then do X, like you can totally program that. Yeah.
One second before we take the next question. Could you repeat the question for the audio recording?
Sure, yeah. So the question, put simply, was like, can you support multiple like trigger types? And yeah, the basic answer is yes. Yeah.
Going off that, does each crank like have its own trigger type, or does like the initial crank have a trigger?
It's just that initial one, it will fire where the trigger condition is met. And then from that point on, the cranks are just like self-generating in a way, like each, yeah.
I'm not really very familiar with Clockwork, but how many, like on average, like how many cranks would you have per program?
It very much depends on like what you're building. So for like a basic payroll system, let's say like you want to schedule a token transfer to happen every week. The queue itself would be very simple. Like there's a kickoff instruction, and that might enqueue some second crank to actually do the token transfer, or you could potentially even do the token transfer in that first kickoff instruction, and that would be the extent of that queue's life cycle, so to speak. But you could also get, like on the other side of that, long-running queues that go on forever. So we have this example program we built for basically cranking serum markets. And it just cycles between like these two instructions back and forth that reads some data and then like writes some data, and reads some data and writes some data. And working together, it cranks serum markets. So it'll do like the order matching on the order book and actually does the settlement. And you know, that program is written to just run forever. And the queue is immediate. It just like fires as soon as it's created and just keeps going.
Can you also repeat the question again?
Yeah. Question was just, yeah, do the cranks have, does the first crank have a trigger, or do all the cranks have triggers? And yeah. Yeah.
So you're saying you can essentially have cyclical like cranks. Like how do you calculate fees on the crank that you run forever?
Yeah, so the way that the fees work is when you create a queue, the owner will just top it up with Sol. And then on every crank, you know, that 1,000 lamp ports gets debited from that queue's balance and paid out to the worker that actually submitted the transaction. And so as long as there's Sol in that queue account's balance, it will keep running. And they just have to maintain that balance.
But that account is also paying like the actual Solana transaction balance too, right?
Yeah.
Per transaction, or do you
Yeah.
guys pay that?
No, they do pay that, and we provide some mechanisms to basically, you can set the rate that you want that queue to crank at, like how many cranks per slot. And so through that, you can kind of manage like how many transactions are you really submitting. And so it doesn't really map one-to-one is the hard part. Like you could have 10 cranks in a single slot or in a single transaction, really. And so you're paying the 5,000 base lamp ports plus the extra like 10,000 lamp ports for each crank. Yeah.
For the cron triggers, how are you tracking time? Is it the cluster time or some other time?
No, it is the Solana clock time. So you know, this gets into like general relativity kind of, but like if Solana drifts from your local wall time, like Clockwork is synced to Solana time, not to, yeah.
Yeah, I was just wondering because there have been times when the Solana clock is drifted, right?
Yeah. So we have been exploring potentially integrating with Switchboard to have like a backup clock that would account for that skew. We haven't done that yet, but it's,
Is PIF also bringing time data on-chain?
As far as I know, they only do pricing data.
Yeah. But that probably also has a timestamp, right?
That's, yeah, good point. I would imagine so.
Yeah.
I imagine your pricing data has to have some sort of time that is associated with, yeah.
Okay.
Yeah. But cool.
Great.
Yeah, if there's anyone
Another
else.
round of applause.